So far we've seen how the coordinates, and more specifically the latitude, affects the sun's trajectory. Now we're going to have a look at what happens as we move from January to December, so throughout the year. Just to go a little bit back, so what we said is that the latitude is actually affecting the inclination of the circle. And now we're going to see what happens as I move from January to December. So let's have a look. So from January to December, basically happens is that the circle's position is actually changing on the sky, in the celestial sphere. So it's also actually bigger and smaller. And as you can see, there is some kind of oscillation as I move from January to December. There is a peak point and then we go back. So what that basically means is that we don't really have a fixed point where the sun rises and it sets. It's actually changing throughout the year. You see, it's not a constant, and that affects how long we see the sun on the sky. So if the entire circle is the sun's trajectory, the part of the daytime, the part of the day that we actually see the sun is above the horizon, is this arc right over here. So let's try first of all to find out when through the year we actually can see the sun rise and set on exactly the east and the west. So I'm going to move my cursor here. So we have one day somewhere around here, so that will be somewhere around the 23rd of December. And if I try to move a little bit more, I can see that there is one more point, which is somewhere around here, so around 29th, 20th, 21st of March. So what does exactly that mean? That is, those are the days, so one in March and one in September, when the sun rises exactly on the east and sets exactly on the west. That also means that the part of the circle that we see is exactly half. So that is the arc that we see, and it's half a circle. So what it means is that we have equal amount of daytime and nighttime. This is what we call the equinox, and we have two of those throughout the year, one towards the end of March, and one towards the end of September. Now let's try to find the biggest possible arc that we can get and the smallest one. So I'm going to move my cursor again, and I can see that somewhere around here, so that is somewhere around the 20th and 22nd of June, I have the biggest possible arc above the horizon. So that means the biggest possible day, the longest path of the sun on the sky above the horizon. That is the summer solstice, and we have the biggest day of the year for the northern hemisphere and the smallest day for the southern hemisphere. Now if I move forward, I can see that the lowest part is again somewhere around December. That would be around somewhere between December 20 to 23rd. So this is the time of the year that I have the smallest possible arc for the northern hemisphere. So the sun rises as further from the east as possible and sets as further from the west as possible. So that is the smallest day of the year that I have, because the sun's path on the sky is the smallest possible, and at the same time at the southern hemisphere I have the longest possible day. Now, so that is how the time of the year changes what we see on the sky. And as you may have noticed, I haven't changed my location at all. This whole time I've been somewhere around here, somewhere around in Europe. So what you can do is you can ask your students to play using a fixed location, and then you can also start changing location as well, and then you can mix a little bit of both.